Hello everybody, let's study software engineering. So in today's class we are going to do evolving role of our software crisis problem and causes and various software paradigms. Now welcome to the first slide. So here it is. We are going to discuss about introduction of software engineering. Now before I know about software engineering, I must know about the engineer term. Which engineer? Engineer is someone who creates, design, constructs, builds, devise and invent. Now, how does the engineer does all that activities? How is the question? Now, in order to answer this, you must follow certain rules or a procedure in order to engineer it. That's why we call it as engineering. The application of scientific or empirical methods to create a utility. What is utility? Utility is a product. It's a deliverable. Now, in our case, it's a software. We are a software designer, software developer. That means software is a deliverable, software is a utility. Now we call it as software is a developed or engineered, but it is not manufactured. When we are talking about software, we must also know that software does not wear out. That means software does not go old, but it go old. Why it goes old? When it goes old, it has to be changed, isn't it? So that change has to be incorporated. We'll see that on the later classes, but then here we would like to come to a point where the definition of software engineering goes like this. It's a systematic, disciplined, quantifiable approach to the development, operation and maintenance of a software. That's a deliverable. That is the application of engineering to a particular software. Now I create the software through software engineering. Now on this slide, we will talk about the software evolution. Evolve in the sense it requires certain changes and it requires certain maintenance. Now when we talk about software change, change required in various terms like it is incompatible or there is a hardware change or there is a requirement change. So many things can happen so that software needs a change as well as maintenance. So in some way a change is also known as maintenance. Now, when we talk about this, we need to look at the rate of the failure as well as the time diagram. Now, here you can see the first half is a decreasing failure rate, middle one is the constant failure rate, and the other one is increasing failure rate. At the end, you can see that there is a early infant mortality failure. That means first, initially it can fail, and lastly it can fail. In between, there is no failure at all. Similarly, and this is the idealized graph plot wherein you can see that the failure rate is maximum at the beginning and very low at the end. But then there is a increasing order of failure due to various side effects, like the side effects can be various requirement changes, various software changes or technology changes or many other ways. Now when we talk about failure and maintenance, there is a layman's law. In one side, it says that according to this law, it says that on one side, the size of a complexity of a software system will continually increase on its lifetime, as well as the quality of a software will decrease. Now, in the end, to conclude, a software evolve because of change and maintenance. Now, let us talk about the requirement of software engineering. Why is it required? Why software engineering is required? Because the individual and society, everyone is relying nowadays on advanced software systems, isn't it? So, and we also need to be able to produce a reliable and trustworthy systems economically and very quickly. As well as the fact of the matter is the software engineering methods used and the techniques for software systems are just not only to write the programs as it is done in our personal programming projects, but it is to follow certain engineering methods and techniques so that a bigger software is made and reliable as well as trustworthy software systems can be made. Now once the software is made, what are the possibility of that software being a good software? Now here we have a few points which is being raised by various authors that maintainability has to be the primary concern. That means it has to be written in such a way that it should evolve certain changes in the software making. If certain change is required by the customer, it has to be implied on. Next is dependability and security. The software has to be secure, it has to be reliable, it has to be safe. Then only the software is a good software. Next is the efficiency. Efficiency in the sense, what are we doing it, and how responsiveness, how processing time and memory utilization is effectively used in that particular software. And next is acceptability. It should be acceptable to all types of user, isn't it? So it has to be understandable, and it has to be usable and compatible with all the. Now, with the basic knowledge, what we have done, we have understood the term called software. It's a computer program, it's a data structure, and it is associated with the documentation as well. And we have also seen the attributes of a good software. It has to be functionally, it has to deliver the product, isn't it? Then it has to perform to the user, and it has to be maintainable, dependable, and usable. That's all we have seen it. And also we have known that what is software engineering. Software engineering is a discipline that concerned with all aspects of software productions. Now here we would like to see the difference between software engineering and computer science. Computer science is the broader sense, and software engineering is practicalities of developing and delivering certain useful softwares. We must also see the difference between the software engineering and system engineering. System engineering is concerned with all the aspects of computer based systems, developing hardware, software, process engineering, etc. But software engineering is only for the general process. Okay, now the software is made in the olden days. Now, what was the gap? There was certainly a gap. Look at the pictures I have put out here. It was way back 1966. Look at the diagram. So the picture says that people are worried about the software. They are not happy about the software because they are worried about the software. Why? Because it developed a crisis in terms of gap in between the user and the software, and user and the software and the hardware, all that. Now we've seen about the crisis, right? Gaps. What was the crisis? What was the gaps during that period of time? Was there was a huge project failure because there was less of manpower, less of knowledge, less of usage. So big project failed, and cost was, and the budget was also overrun because there was no software engineering at that point of time, and software were not reliable. It was very difficult to maintain at that point of time, and it was difficult to meet the user requirements because user requirements kept on changing because it was the initial phase of the software development. So more and more computers and programming language powerful it became, isn't it? Computer became powerful, and then software become less powerful. So there was a gap. So in order to bridge that gap, gradually what happened, people understand to learn about software engineering, and they started to follow certain methods of making of a software so that all these crises will be met. Now also you must also note down these crisis. See, there's a demand growth. The demand grew, isn't it? When the software was in the market, everyone wanted to use that software. It grew. Then more complex requirement came into existence, and software itself became very complex. In order to develop the software itself become very complex, and lot of people were involved in that particular software making process. And gradually what happened, the professional skills and methodology, they started to develop, they started to communicate with the user, and they started to have a teamwork on it, so that finally the software engineering came into existence, wherein they follow certain methods of developing of a software in such a way that it is reliable, it can be maintained, and it can be reusable, it can be rethought, the requirement can be, changes can be made. Now there was a lot of crisis in the beginning, and people thought about having it engineered well. So software engineering came into picture, isn't it? So it first started with the software paradigms. Now in a general sense, paradigm means it's an assumptions, it's a concept, values and practices that constitute a way of viewing the reality for a community that says them, especially in the intellectual discipline. So the process of doing it, the method of doing it, how do we go about it? Now what are the assumptions, what are the concepts do we have to take into consider? Now in our case, in software development case, it is nothing but how a developer view a given problem and organize the solution. There may be multiple solutions, there may be multiple way of doing things, isn't it? So how do we as a product developer view the problem, and organize it in well so that a good solution can be delivered. That is known as software paradigms. Now when we talk about paradigms, no, we are talking about certain methodology of doing it. Now look at the diagram here. I have a real world and I have a product delivery. Now from real world I can go 3-4 ways. See, procedural, data driven, object oriented, or any kind of haphazard way of doing it. Now ultimately we are delivering the product. Now if we follow the engineering approach, now what happens is there has to be a continuous process models. Now it has to follow all the processes. Now one by one effectively it has to follow the processes. Now what are the processes? The processes are none other than the activities. That activities for a effective delivery of a software engineering. Now certain models can be followed, like models that represent a data, that represent a report, that represent forms. Certain models can be followed, certain milestones can be established, certain quality is ensured, and change is managed in that particular model. Now method means how do we technically develop that particular software. How do we do it? How do we communicate? How do we do requirement analysis? How do we do modeling? How do we do construction testing, and all other things? Now similarly, to do that we need a certain tools. It could be a automated or semi-automated support system for all the process and the model. Now here I am representing a level of the layers approach. Lower layer you've seen. On top of that you have a one more layer, and there is a one more layer, and it's a layer approach of a process delivery. Now when it is delivered, lowest layer is the quality, the biggest one. Then comes the process model. What kind of process modeling I am following? Then comes the methods. What kind of methods I am following to reach at the particular level? And finally there are tools. So the process is a collection of activities, action, and tasks that are performed, and the purpose of a process is to deliver a software in a timely manner and with a sufficient quality to satisfy those who have sponsored this creation. Now see, when we talk about a layered approach, process layered approach, we must understand the word process which is associated with the software. Now what is software process? Software process means it's a regulatory framework that includes activities, action, and tasks that are required to build a high quality software. So it's a framework of activities. Now you can see the activities there. It's a bigger one, software process. Then you have a process framework. Then you have a umbrella activities. Inside that there are small activities mentioned on it. So entirely it covers a framework. It's a generic one, generic one. Now a generic process framework for a software engineering has 5 different components. One is communication. How do you communicate? One is planning. How do you plan your project? Next is modeling. What kind of modeling are you following? Next is construction, matlab implementation. How do you implement it? And then finally a deployment, commissioning at the user end. How are you deploying it? And apart from that, you must also know the certain umbrella activities. That means how are you tracking the project improvements? How are you changing the risk management? How are you doing the quality assurance? How configuration is managed? How technical reviews are done? All this comes under your umbrella activities. Hopefully I have made all of you clear on the basic terminology of software engineering. What are the process involved, the software process, and the layer approach, and various activities, the generic activities that could be used to develop any product as a deliverables. Now next class we will see the different types of process modeling. Okay.